Good evening, welcome back to the Jobs and Educational YouTube channel. Now here we are going to see some more previous physics ECET questions. Let's see the first question. Here the question reads, a ball rolled on ice with a velocity 8 meter per second comes to rest after traveling 40 meters. Here he given velocity equals to 8 meter per second and it comes to rest after traveling 40 meters. He given distance 40 meters, and if the value of g equals to 9.8 meter per second square, acceleration due to gravity value 9.8 meter per second square. The coefficient of friction, he is asking to find the coefficient of friction k. Options read 0.328, 0.0816, 0.0416, 0.258. Let's see the answer. Here weight equals to reaction, that is equals to mg, mass into acceleration due to gravity. Frictional force equals to k into mass into acceleration due to gravity. Work done sliding to rest, before it coming to 40 meters it came to rest, so work done sliding to rest is force into distance, which is nothing but kmg into distance. Now this is equals to kinetic energy. Now km dg equals to half mv square. Now by substituting the value of m and v equals to 8 meter per second and distance 40 meters and g 9.8 value, m equals to 1, we will get k equals to 0.08 and the answer is 0.0816. Second option is correct. Now next question, which one of the following is not the unit of energy? He is asking from these four options which is not the unit of energy. We know that energy is in the SI units of joules or Newton meter. He given that kilowatt hour, joule, Newton meter. Joule is correct, Newton meter is correct, and kilowatt hour is also correct. In energy meters we'll get the units in kilowatt hour, but kilowatt is the units of power, so it is not the unit of energy. The following which is not the unit of energy is kilowatt. Next question, the principle of conservation of energy states that option A, sum of all types of energies is conserved, total mechanical energy is conserved, total kinetic energy is conserved, total potential energy is conserved. Here according to conservation of energy, law of conservation of energy, all energies are conserved or can be converted from one form to another, but not only mechanical energy, not only kinetic energy, not only potential energy. Sum of all types of energies is conserved. Now next question, for a body moving in simple harmonic motion, a body moving in simple harmonic motion SHM, the number of cycles per second is known as its, the number of cycles per 1 second is known as frequency. The answer is frequency. Next question, the acceleration of particle executing SHM when it is at mean position. When it is at mean position, suppose if we take a particle executing SHM, when it is at mean position, the acceleration of that particle is option A infinite, option B 0, option C maximum, option D unity. Here at mean position the acceleration of particle is 0. At mean position, when a particle is moving in SHM simple harmonic motion, at mean position its acceleration is 0. Next question, the longitudinal waves cannot, the longitudinal waves cannot, option A have a unique wave velocity, option B be polarized, option C have a unique wavelength, option D transmit energy. He is asking that longitudinal waves cannot, select the option which is not related to longitudinal waves from this four option. Here the longitudinal waves can have unique wave velocity, can have unique wavelength and can transmit energy, but it cannot be polarized. Longitudinal waves cannot be polarized. Next question, stress is asking that stress is what? We know that stress for a human sometimes he gets stressed, which is nothing but internal force or internal resistive force. Stress is nothing but the force which is developed internally. Suppose if we take a body, the internally developed self-developed force is nothing but the stress. Stress is denoted by sigma here. So he given the options: external force, internal resistive force, axial force, radial force. Stress is nothing but internal resistive force. Option B is correct. Here the question reads, which of the following statements is false? He is asking the false statement from the given four options. Option A, viscosity is independent of the surface area of liquid layers in contact. He is saying that viscosity is independent of the surface area of liquid layers in contact. Viscosity of a fluid changes with temperature. The dimensions of viscosity is same as that of product of pressure and time. The viscous force is directed opposite to the direction of motion of liquid. Here, let's see the second option. Viscosity of fluid changes its temperature. When the temperature of a substance or liquid or gas or solid increases, its viscosity changes, but it does not remain constant. So this option is correct. Let's see the third option. The dimensions of viscosity is same as the product of pressure and time. Units of pressure are Newton per meter square, and product of pressure and time second, Newton second per meter square. Here the dimensions of viscosity are Newton second per meter square. This is correct. This is correct. And the fourth option, the viscous force is directed opposite to the direction of motion of liquid. If suppose a slant is there, here the liquid is coming in this direction, downward direction, the viscous force of the liquid will be in upward direction. This statement is also correct. These three statements are correct, but viscosity is independent of the surface area of liquid layers in contact. It is not independent, it is depend on surface area of liquid. So this first option is the wrong statement given about the viscosity. Now let's see the next question. Here the question given, a wire having uniform diameter, a wire having uniform diameter, assume d, and length, this total length is L, so and have a resistance R. Another wire having same material, these two are same material, but having diameter 2d, diameter is 2d, and length is 4L. Then its resistance will be, he is asking what is the resistance. If a wire of diameter d and length L having a resistance R, then what about the same material having diameter 2d and length 4L? Let's see the options. Option A R, option B R by 2, option C R by 4, option D 2R. Let's see the answer. Here given R equals to PL by pi by 4 d square whole square. He given the first wire R equals to P into length by pi d square by 4 whole square, and the second wire R dash, P into length is 4L and pi by 4 d square, but he given the diameter is 2d whole square. Now by squaring these two we get P 4L by taken 4 outside, pi d square by 4. So this 4 is cancelled. R dash is also equals to PL by pi by 4 d square. Here again this R dash is equals to R. The both wires having the same resistance. So the option A is correct. Now let's see the next question. In a meter bridge experiment, the ratio of left gap resistance to right gap resistance is 2:3. The balance point from left is given that in a meter bridge experiment, the ratio of left gap resistance to right gap resistance means, assume L by R equals to 2 by 3. The balance point from the left he is asking the balance point. Let's see the options. A 40 centimeters, B 45 centimeters, C 60 centimeters, D 65 centimeters. Now let's see the answer. Assume the left gap as x and the right gap as r. L1 be the balance point from the left. From meter bridge experiment principle, x by r, left gap by right gap is equals to, from left the balance point is L and from the right 100 minus L. So he is given the 2 by 3. Now equating this, L by 100 minus L1 equals to 2 by 3. We'll get 200 minus 2L1, that is equals to 3L1. 200 equals to 5L1. L1 equals to 200 by 5, which is nothing but L1 equals to 40 centimeters. Here given that left gap by right gap equals to 2 by 3, but left gap by right gap equals to L1 by 100 minus L1. Equating this, L1 by 100 minus L1 equals to 2 by 3, we'll get L1 equals to 40 centimeters.